Okay, students. So we're going to go ahead and start with Unit 2, Empirical Research, Hypotheses, and Variables. I'm going to warn you, today's lecture is going to be fairly long. We're going to be covering 2 units, and so I'm going to just try and dive right into it. The first thing we're going to do is we're going to talk about empirical research. I know we discussed it a little bit, but we're going to dive a little bit deeper into it. So our objectives for today, we're going to talk about what empirical research is, dive deeper into what that is. We're going to talk about research versus experience. Then we'll talk about bias and overall what bias is. It's not exactly a good thing, but it's unavoidable, so we need to talk about it. And then we're going to talk about finding empirical research and ways that we can get to it. So what is empirical research? Last time I mentioned to you that's about measuring kind of these senses. Well, overall, we're trying to measure phenomena. We're gathering evidence. We're gathering it in a systematic and rigorous way. So the phenomena that we're measuring is some sort of outcome variable. Like, for example, we're trying to measure depression. Now, depression can't really be measured by the senses, so we have to go by different ways of measuring that. This is through scales and so forth. And the way we do that is we gather evidence over and over again in order to try and get at what that phenomena overall is. And we do this in a systematic and rigorous way. So let's talk about what is empirical research versus which is not empirical research. Experience can be a part of empirical research, but the difference is it's subjective. Additionally, it only counts for one person, and that person being you. It's very anecdotal in a sense, and we can't exactly account for it. We can't exactly control for these experiences. Whereas actual research is the true empirical way of looking at things. It's systematic, it's probabilistic, it utilizes data, and we utilize multiple accounts. It's not just you anymore, but rather we're utilizing the aggregate sum of many people in research. So really, this is a research methods class, so we're not going to be focusing on experience at all. I'm not going to be talking about the anecdotal part of what you experience versus what I experience. We're going to talk about the aggregate sum of individuals overall. So there's a lot of problems with using experience versus research. The first of that being biases. Now, bias is a systematic error. This is different than random error. I want that to be clear. This is an error that keeps happening in one systematic way, right? Whereas random error, it pops up everywhere. Random error is actually not something that we're very worried about in research or even experience. Random error is just random error. We can't control for it. However, biases are potentially controlled for, so we can control for those. However, in experience, we can't control for a lot of these biases. Now, there's 4 main biases that are really prevalent within experience. The first is the availability heuristic. Now, availability heuristic is things that pop up easily in our mind tend to guide our thinking. So think about this in a cultural phenomenon. If something is very deeply prevalent in your culture, you're going to think in that way. However, that's not accounting for some other culture. The present bias is a failure to consider appropriate comparison groups. So think about what this means. When you're comparing things to yourself, you're not comparing things with how someone else might subjectively experience this, right? So it's not really getting at anything when you're doing this experience. The next term is confirmation bias. Confirmation bias is this tendency to look only at information that agrees with our beliefs, right? With experience, we tend to have our own beliefs. So when we have these experiences, we say, oh, this must be what this is. So confirmation bias is especially present in experience, in which with research we hope to control for. Lastly, we have the bias blind spot. This is really the belief that we're unlikely to fall prey to biases at all, that we kind of know everything. Whereas we don't have data, we don't have research to support it. How can we say it that any differently? So the bias blind spot is saying that, yeah, I don't fall into biases. I am perfect in myself. So those are really just 4 problems that are experienced within experience. And there's a lot more, but I don't really have enough time to go through each of them. But I want this to be very clear. Bias still exists in research. Bias is extremely prevalent in research, actually. And we're going to talk about the way that it affects it overall. However, it has your research will always have less biases present than experience. Your experience has those 4 very prevalent biases that we can hopefully control for when we do actual research. So it's just a very important point. We're still not out of the woods yet. Bias is still going to be there. It's still going to be something. We're always going to have some sort of systematic error. The difference in research is we're able to actually control for it and actually account for these biases much better than you would with experience. So, however, a large goal of research is to systematically reduce our bias. One of the biases that is especially reduced is the bias blind spot because we as a researcher acknowledge the potential for bias. We're already helping ourselves out by doing that. Whereas with experience, it's very hard to really account for your own biases. So your bias blind spot is relatively large. You don't know what biases you're prone to. Whereas research, we're able to actually go look for them and acknowledge that this exists. So even though biases always exist, we're always trying to reduce them as much as we can. And I really wanted to talk there's a lot of different types of biases that we don't have time to go into much detail about, but they really exist. Design bias, the way that you design your study in itself has bias in itself. Sampling bias, we'll talk about how to do sampling selection later on in this course. Measurement bias, every single measurement you take has some sort of bias associated with it. Interviewing bias, in the case where you have interviewers to do qualitative research or research that isn't really numerical in a sense and where they're just trying to get information through um, people, there might be differences in interviewers, the way that they conduct the interview, and many, many, many more biases. So really what I'm trying to get at is that even though we are trying to reduce biases, there's so many different biases which are systematic error that exist within our type of research. And they're really hard to avoid, but we can do the best we can in research. We do the best. This is the closest that we can get. Okay, so you might be asking yourself, what does bias do to a study? Well, for this next set exercise, what I'd like you to do is kind of imagine that you're throwing darts at a dartboard, right? Uh, to be on the top left image, you see that to be unbiased and precise, you're hitting every single dart there. Whereas if you're biased and precise, you're throwing the darts, but they're slightly off from the actual answer to the solution. And being unbiased and imprecise means that it's probably the worst one to have, where you simply are just throwing darts randomly and they're not getting anywhere. Biased and precise means that you are kind of going towards, you're kind of in one section of the quadrant, but you're not really precise in there. So what I'd like us to know is that being unbiased and completely precise is pretty much impossible. We're ideally looking to have some bias because, like I said, we can't get rid of bias. It's completely impossible. However, we can try to be as precise as possible. And I want you to imagine, remember, each of those darts are an individual study that is trying to get at some answer to some outcome variable. So let's say we're studying depression. We say, how prevalent is depression in the American population? We're throwing at the dartboard saying, we think it's right here. We know the bias exists, but we're trying to be as precise as possible. Although that's ideal, the truth of the matter is oftentimes we find ourselves all over the dartboard. That's because there's a lot of different biases that exist. It's really hard to control for all of them. And really, we do the best that we can. Some outcome variables are easier to measure than others. Some have better tendency to have better experimental studies associated with them. Some things we can't do experimental studies with them. So we have these less precise and more biased estimates. So the unfortunate reality is that we're in this lower quadrant, the less good ones. But We would prefer to be in that ideal place where bias is the only thing that's keeping us from there. Because then we can at least say, well, we know we're biased to some degree. What can we do to try and envision ourselves in this unbiased world? So what can we do to reduce bias? Well, there's a lot of different biases, right? So that means there's lots of different ways to control for bias or to reduce bias. However, that also means there's a lot of different ways to reduce bias, which means that there's so many different ways, it's hard in one study to reduce every single bias. And these sometimes are associated with each other. So when you reduce one, you increase another, and it becomes very complex and complicated. So really, you have to kind of hedge your bets a lot of the time. Each of these biases has a specific way to reduce it or to increase it. And remember, the goal is to reduce it as much as possible. Throughout this course, you're actually going to be learning about how we can decrease some of these biases. For example, measurement bias is a way that we can is a really practical way to try and decrease bias. Because our measures that we use to, a measure that would measure something like depression or anxiety, we have ways of controlling for the biases that exist and seeing we can actually account for how much bias is associated with our measure. We can also reduce interviewer bias by training our interviewers or blinding them to the study. Blinding them meaning not letting them know what types of conditions exist, what the study is about, or anything like that. Or properly training your interviewers saying, hey, we have an exact protocol that you shouldn't deviate from in order to reduce the bias. So there's a lot of different ways to do this, but each of them requires their own specific set of criteria and material and effort in order to reduce it. And it's a very complicated process, actually. So now I want to switch gears a little bit and go back to kind of what we're talking about with empirical research. So how do we find empirical research? And this is research that really controls for those biases, that actually takes into account and is not subjective in experience. It's not an experience way of looking at things. However, it is a way of doing actual research. So some of the ways that we can find actual empirical research, and I kind of rank them by what is the most desired and least desired way of finding it. The most desired is called going through a primary source. A primary source is something that it directly did the study, and you're the one that's reading the direct effects of the study. For example, scientific journal articles are a great way to do this. And later in the course, I'm going to teach you how to actually search and find these scientific journal articles in a systematic way where you find research where they actually, in a way, try to control for biases and kind of engage in empirical research. Chapters in books, like a textbook, for example, your Morling book that you have, oftentimes cites very famous studies. The more recent the textbook, probably the better. Or topic-specific books. There's a lot of books that focus on statistics and psychology, or anxiety and psychology, personality psychology books. Those are probably pretty good primary sources to find a lot of information on empirical research. Another way of finding it is honestly through Wikipedia and professional blogs. It's a little less desired because you have to question the validity of the source, but I think honestly Wikipedia is a relatively good way of finding information. I think it's a great way to start. Oftentimes, if I don't know much about a theory, I'll start through Wikipedia so I can get a good understanding of the kind of outline of it, and they'll oftentimes cite a lot of really famous studies associated with it. And then I'll go on to the more desired scientific journals, just so I have a background knowledge and understanding. I think Wikipedia has changed a lot. They've become a lot more credible over the years in the ways that they cite all their sources, but it's still a less desired way. And now, given that on your papers, that means I do not want to see you citing Wikipedia at all. You will be, in your papers, when we get to that, only citing scientific journal articles or chapters in books. And you'll actually learn how to properly cite those exact things in APA formatting. And then the least desired way is the popular media. And we hear a lot about fake news. We hear a lot about all these things. They really sway it a lot. Although it's a good information and you should watch the news, it's a great way to get information about the world. You should take everything with a grain of salt and not really um, think too hard about it until you've read it through these other higher desired ways of looking into the actual scientific research. These is popular media is where we get things like, wine and chocolate can save your life. They're weight reducing when really there was not very much evidence to support that, or they kind of swapped the journal up on its head and made it seem like it's really something more than it really is. So the next part that I want to talk about is we're going to go and talk about hypotheses and variables. This is where we're going to learn how to actually write about hypotheses. So the objectives for this is we're going to talk about different types of variables, operationalization, we'll talk about that term when we get to, and then independent measures, and then we'll talk about actually formulating hypotheses. So the first thing I'd like to talk about is what is a variable. A variable is, simply put, something that varies. So think about it in this way. Height varies from individual to individual. If we are all the same height across the board, that wouldn't be a variable anymore. However, we know that height very much differs from individual to individual. It varies across sex as well. There's a different average for males than there is for females. Anxiety levels are different across people as well. So these very much vary from individual to individual. So all of these variables have something called levels, otherwise known as a value. You can either be male or female or another gender of some sort. You can be transgender. Additionally, we can talk about two different types of variables. The first one we're going to talk about is a measured variable. A measured variable is simply a variable that you observed and recorded. So what that means is something like height or age. You simply ask a person, how old are you? And they give you an answer. They say, I am 26. And then they will simply tell you their age, and then you record that. That's simply put a measured variable. Additionally, there's something called manipulated variables. Manipulated variables are variables that a researcher can control and change. This is when we start getting into things like study conditions. This is where a researcher says, I'm going to say in one condition we have some aspect associated with it. And one condition there will be a deer head on the wall. On the other condition there will not be a deer head on the wall, and we'll study some sort of measured variable in the end. So when we get into experimental studies, we'll really be digging into what these manipulated variables are. And additionally, we'll be talking about measured variables, because your measured variables are always the outcome variable of interest. You don't ever have an outcome variable be your manipulated variable. It wouldn't really make too much sense. At least not that I can think of. If you can think of one, let me know. I would love to see it in an email. The next thing I'd like to talk about is operationalization. This is the idea of turning a conceptual variable into an operationalized variable. So what's a conceptual variable? Well, a conceptual variable is a variable that is not able to be observed directly. Think about it this way. Things like depression. I can't observe your depression directly, so we use things like depression measures to indirectly measure your depression levels. Or same with anxiety. It's not like height, where we can actually go and see your physical height and measure it with a ruler. We have to go about indirect ways of measuring it. So a conceptual variable is something that can't really be measured through sensical means, but we have to measure it through some indirect way. So that's why we use this term called operationalization, so that we can actually measure a conceptual variable. A conceptual variable being something like depression or anxiety, where we actually turn it into something measurable through these measures. And in the next slide, I actually have an example of what that looks like. So here's an example of what it is. We operationalize them through something called constructs. A construct is an operationalized conceptual variable. We often create constructs by creating a series of questions to measure the conceptual variable. So on the right here is a measure called the Center for Epidemiological Studies Depression Scale. This is a really famous measure that you likely will at some point encounter sometime throughout your psychological career here at CSU. As you can see that it asks questions saying something like, during the past week, I was bothered by things that usually don't bother me, and it asks the participant to ask how often they experience these kinds of um, these symptoms of depression. And from there, we're trying to actually operationalize this conceptual variable through this construct that's the construct of depression. So what we do is just simply ask questions that are related to that. Now, this is a really complicated subject because you can't just ask questions and assume that everything that you're doing is correctly measuring that conceptual variable. We're really going to dig more into this in our next unit, actually within the same lecture, where we'll talk about how we can actually measure these conceptual variables and the ways that we get at it. Now, remember that term bias that I talked about before? This is the same exact thing. A lot of biases exist when we measure these conceptual variables, and it's difficult to get around them, so we have to think of unique ways to talk about them. So you've learned a little bit about what variables are. Now we can talk about what specific types of variables there are. One type of variable that I'm sure you heard about in Psychology 100 was an independent variable. An independent variable is simply a manipulated variable in an experiment. Remember when I talked about manipulated variables? That was something like a condition being manipulated, where I talked about the deer head being in a room versus it being not in another room. That would be an idea of a manipulated variable to see what it is. Your dependent variable is really your outcome of interest. This is something that's measured. It's never manipulated in any way. It's measured outcome variable in an experiment. Now, the reason I say in an experiment, and actually both of these in an experiment, is because these are specific terms to an experimental study that can only be used in an experiment. I'm pretty big on this. I really believe that these are very specific terms for specific times. But really what we're talking about is an independent variable causes the dependent variable. So think about it this way. If I manipulate some condition of a study, let's say I make it so that there's loud music in one room and I put no music in another room, and I see how that does on something like test scores, right? So if somebody is trying to take a test with really loud heavy metal music, they might vote. My hypothesis would be I hypothesize that individuals in the heavy metal music condition will do worse than individuals in the no music condition, because I would think that it would be distracting towards their test. You might have a different hypothesis, but that's my hypothesis. But really what it's saying is an independent variable causes the dependent variable is what we're saying. So in the loud music causes the lower test scores. Now, when it's not an experiment, we have different variables. Because we're not talking about cause and effect anymore, we have to use different variable names. So when it's not an experiment, your independent variable is called a predictor variable, and it's not necessarily manipulated, but is rather observed as well. And your dependent variable is known as your outcome variable. Now, I'd make sure I remember these for the test because I really am a big stickler about this. Remember? So if it's an observational study of some sort, it's called a predictor variable. If it's an experimental study, it's called an independent variable. And same with the dependent variable is used only for experimental studies, and outcome variable is used for observational studies. Let's go ahead and talk about hypotheses. So what is a hypothesis? We talked about it a little bit before, but now we're about to dig in a little bit deeper as to what a hypothesis is. So a hypothesis is a specific answer the researcher expects to observe in a study, right? So it involves the relationship of two variables, right? So I'm saying I hypothesize that something is related to something else. In an experimental study, I am talking about the relationship between the independent variable and the dependent variable. And really, I'm actually talking about the cause and effect between the independent variable and the dependent variable when I'm talking about an experimental study. Now, I say that word cause because experimentals can have some causal effects. I say that kind of with a grain of salt because even then we're still unsure sometimes. It depends on how the experiment was set up if we can talk about causal claims. But here it could potentially be the cause between the independent variable causing the dependent variable. If it's an observational study, it's a relationship between your main predictor of interest and the outcome variable. Now, it's not saying anything causal when we're talking about the observational study, because observational studies are not causal. So what makes a good hypothesis, right? So hypothesis, there's a lot of things that make it good, right? And it's actually very similar to what makes a good theory. It's, first of all, it's built from a theory if it's a good hypothesis. You don't just formulate the answer to your research question based off of nothing, right? Maybe through some sort of basic research you would, but when we're talking about translational or applied research, we'll better make sure we have a really good hypothesis that's built from a theory. Additionally, it's the same thing that's associated with the theory, is that it's falsifiable, right? We're saying the answer to this question with the expectation that it could be wrong. And that's the point, is that we have the ability that this could be wrong. Additionally, it's operationalized, right? So it's that term we learned a little bit earlier, where we're saying that we're turning conceptual variable in some way. This variable can be measured, is what we're saying. Additionally, you have a clear population of interest. I'm a pretty big stickler on this one too. So this means when I define my hypothesis, I'm saying college students at CSU are anticipated to blank, 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 right? I have a very clear population. Or I'm saying veterans in America are expected to do something in some way. It additionally shows a clear relationship between variables. In an experimental study, you're showing the clear relationship between the independent variable and the dependent variable, whereas in an observational study, you're showing that clear relationship between the predictor and the outcome. Additionally, it can be tested in some way. This is either through manipulating conditions or just measuring things in all ways. Everything has to be operationalized and measured in some way or manipulated in some way. Another big thing is in a true hypothesis, it has a comparison group. It's a little bit different with the basic research principles, but when we're talking about things in translational and practical research, we have a clear comparison group that we can talk about. Because if you can't compare it to anything, then it's obviously basically like subjective experience. And we need to have some sort of comparison group to say, look, it did this way in comparison to this other group. It did better, it did worse, it did the same as this comparison group. So really there was no effect because of this, is what we're kind of focusing on and what makes a good hypothesis. So I have a couple of examples that I wanted to kind of talk through with these example hypotheses. So first of all, my first hypothesis is students who eat breakfast will perform better on a math exam than students who do not eat breakfast. So I have a clear population of interest, that's my students. Everything's operationalized in some way. I can measure whether you ate breakfast or not. I can manipulate it so that someone doesn't eat breakfast. Or if I had them come into a room, I can manipulate it so that there is a breakfast condition or no breakfast condition. I have a clear operationalized variable, like a math exam, so I can test math ability through this math exam, right, to see what their scores. It's operationalized in a way. Additionally, I have a very clear comparison group, right, than students who do not eat breakfast, right? And additionally, my next one is motorists, my population of interest, who talk on the phone. So motorists who talk on the phone is my population of interest, while driving will be more likely to make errors on a driving course. So I can actually measure things through a driving course because there's a scoring system associated with it than those who do not talk on the phone. So my comparison group is those who do not talk on a phone. And so what I've done is I've actually colored things that are associated with this. So in red, we have your population of interest. I also have the true IV/predictor, so who eat breakfast will, and then our outcome of interest will perform better on a math exam than the students who do not eat breakfast. So I'm interested in my IV/predictor is students who eat breakfast, breakfast versus no breakfast as some sort of manipulated variable. Additionally, I have my outcome of interest, which is to perform better on a math exam than students who do not eat breakfast. So the reason I colored these is because when you're writing your hypotheses later in this class, I want you to refer back to the slide, and so that you can actually write a good hypothesis that has all these variables present. Now, this doesn't show the aspect of it that's associated with it being based off of a theory, and other things like that, but it does show you kind of the basic formula for writing a hypothesis. So really, your hypothesis should contain all of these facets in it. And I'm going to tell you, this is really going to help you later when you're taking a more advanced research methods course, because hypothesis development, they're going to talk a lot less about how to develop a hypothesis and expect you to be able to do that. So I really would like you to take this with you even beyond this class so that you can understand what it makes a good hypothesis. Now, can a hypothesis be proven? I want to say likely not. I mean, remember, one of our things is that it's falsifiable in a way. However, we can continually acquire evidence towards a hypothesis, right? So the more information we gather, the more evidence we have towards that hypothesis being true. So I want you to go ahead and try creating a hypothesis yourself. I want you to go to the discussion board. Imagine yourself as a researcher trying to answer a research question. Write out one research question. So write out a research question saying, how does something relate to this? And then formulate two hypotheses that set out to answer that research question. Now, I don't want you to get too bogged down whether or not this is a good hypothesis or not. Just try your best, but what I want you to do is see if it has all those elements. It's okay if it's not totally built off of a theory right now. What I want you to practice is that the hypothesis has all those elements present in it. And if you want to, you can even label what those elements are. For me, it'll make it a lot easier for me as well. And then we can kind of talk through, if I see anything, I can talk through about what would make a hypothesis a little bit better or how we can improve it. But the important thing is that you have every single part of that hypothesis present. So, in summary, we engage in empirical research. Bias in research is overall unavoidable, and that's just a sad truth, but we can control some aspects of it. Then there are many ways to find empirical research. That's when I was talking about the scientific articles versus the media or using Wikipedia. Variables are either measured or manipulated. Additionally, we have conceptual variables where we can operationalize them. And then a good hypothesis contains several different attributes that are associated with it. And now we'll be moving on to Unit 3, which is measurement and reliability and validity. These are some of the core components of a lot of psychological research when we're talking about reliability and validity, and they come up a lot throughout any of your other courses. So, some of our objectives. We're going to start off talking about measurement. We're going to compare different measurement styles. We're going to understand different levels of measurement. This is where we're going to talk about some variables again. Then we're going to compare and contrast the reliability measurements we know and know when to use them. Then we're going to talk about validity and compare and contrast different measurements of validity and know what constitutes a valid measure. So let's start off by talking about what measurement is overall. So, measurement is what we use to measure. We use measures to operationalize our variables. So remember those conceptual variables before? These measures, our constructs, are what we're using in order to actually get those conceptual variables. So things like anxiety, depression, self-efficacy, all these other variables that we can't directly measure, we use these measures to actually get at them, right? So it's not like a ruler. We're asking questions or observing phenomena or a different way. So there's three different types of measures that we're going to cover today. There's self-report measures, observational measures, and physiological measures. And we're going to kind of dig into each of these in a little bit more detail in the next following slides. So our first one, self-report. It's probably one of the most common ways that we do reporting and measurement in psychological research. We operationalize through people's answers on questions. So for example, you can ask someone, how old are you? They'll say, I'm 23. Or you can even ask something, say, Are you feeling healthy today? On a scale of 1 to 10, how are you feeling? This is a way that we get at measuring things. So it can either, and there's different ways that we can measure it as well. And we're actually going to get more into that when we get into survey research about, how we measure, are you feeling healthy today? Do we want it to be a yes, no answer, or do we want them to rate it on a scale of 1 to 10? So yeah, as I stated before, it's one of the most common ways to measure variables in psychological research. It comes with its own set of problems though, and we'll kind of discuss this in the next units and really talking about what problems are with self-report and what kind of errors we can talk about. This is where reliability and validity come in, where we can talk about the biases that exist with self-report measures. Next is observational measures, aka behavioral measures. This is where we operationalize. Notice how every time we're operationalizing something, right? So we're turning a conceptual variable into a measured variable. This operationalizes variables through physical characteristics of behavior characteristics. So for example, looking at baseball caps determines someone's favorite baseball team. So you could look at a baseball cap and see that they're wearing a San Diego Padres baseball cap and say, you know what, they're probably a Padres fan. But remember from the first lecture when I stated that I had a Boston cap on, but I am actually a San Diego Padres fan, really that can indicate that, there's errors in the measurement of behavioral research where just because they're wearing a baseball cap, it means probably one of their favorite teams, but it doesn't necessarily mean that it is their favorite team. It might be some other reason they're wearing it. So there are problems that come on with this. Um, counting how many keys someone types in a minute to determine typing speed, that's a way of getting an observational research as well. If I type 30 words per minute, then we can say that my typing speed is 30 words per minute or something like that. Next is physiological. This operationalizes through biological indicators, so something like heart rate or through a PET scan of brain activity. With this way, you can detect instant, in the moment reactions to stimuli. So if I were to kind of prick your finger, and maybe that would increase your heart rate, right? So we can see this direct indication associated with that. It often requires specialized equipment, so heart rate monitor to detect heart rate. Although you can detect pulse by just using your fingers, is one way of checking someone's pulse, right? Or using like a PET and MRI machine, which are oftentimes very expensive, cost a lot of money to utilize. Now, I think oftentimes people think that physiological indicators are kind of the best, but they're just as at risk for biases and error as the other two measurement types. You know, there's always error in counting someone's heart rate or brain activity, and so forth. Although there's very advanced technology, it doesn't necessarily mean we're in the clear. We didn't necessarily measure things outright appropriately without any bias just because it's a physiological measure. So which is best? Really, none of these are best. It depends on your research question. Some things can't even be measured physiologically. It's hard to measure depression physiologically, although we have seen, differences in brain areas in depressed individuals as compared to non-depressed individuals, but we have to capture depression in another way. So we use these self-report measures, right? Or measuring depression through behavioral observations is pretty tough because people don't look sad all the time. Just because you have depression doesn't mean you look sad all the time. So, you know, again, I talked about how people think the physiological measures are the best, but this isn't the case. Although accurate, we cannot measure everything biologically either. And they're still prone to error. But really, it depends on your research question how you are going to measure your variables. So next thing I'd like to talk about are scales of measurement. There are two types of scales of measurement, and we can actually subdivide these even more in the next slides, which I'll be talking about. But the two basic types are categorical variables and quantitative variables. Categorical variables are exactly as they say. They take on different categories. However, the caveat is that none of these categories take an order. For example, in sex, male and female, one isn't any higher or lower than the other. If I place one as a 1 and place one as a 0, it doesn't mean anything. We have to numerically categorize them, though, in order to do some sort of data analysis with them. Another one is race or ethnicity, right? So the differences between black, white, Hispanic, Native American, all these other types of race and ethnicity variables are categorical. None are any better than the others. We can't really put a level to them. Whereas quantitative variables, we can give them this differing levels of, we can say 1 is less than 2, 2 is less than 3, and so on and so on. For example, income, if I'm making $0 to $20,000 a year, that's less than making $21,000 to $40,000 a year. Or age, 16 is more than 15. In height as well, these are very clear what is more and what is less in there, whereas your race and ethnicity and your categorical variables don't take on that same exact aspect. So these categorical and quantitative variables can take on 4 different forms. Now with categorical variables, you're pretty lucky because it only has one form it can take. Any nominal variable is considered a categorical variable. That means it's completely categorical but not ordered in any way. So bird species is a great example of this. A blue jay versus an oriole, like there's no order to what type of species there are here, right? So, and again, we can talk about things like sex. So it's completely categorical. Quantitative variables is where it gets a little bit different. We can start this in different levels. So I'm going to start off with ordinal. This is where your numbers are ordered, but the order isn't equal. So take, for example, marathon race rankings. First place definitely did better than second place in the marathon ranking, but we don't know what the time difference between them is, right? So first place could have finished the marathon in so many minutes, but the second place person could have only been a few seconds behind them, or they could have been 10 minutes behind them. First person, it doesn't necessarily have this true order, whereas if we were timing them, it wouldn't necessarily be an ordinal, it would be a little bit higher level. The next one that we can talk about is interval. This is where the numbers are ordered and are equal. So the difference between 1 and 2 is equal. But the caveat here is that there's no true 0 points. One example of this are called Likert scales. Likert scales are those things that you see on surveys where it says on a scale of 1 to 10, how much do you like this person, or something like that, or on a scale of 1 to 10, how sad are you right now, how happy are you right now. Notice how it's on a scale of 1 to 10, and even if there was a 0, there's no true 0 point because you can't truly measure 0 happiness, right? So that's what an interval scale is. Now ratio scale takes on all these qualities. The numbers are ordered, there's equal, there's a difference between 1 and 2, and a difference between 2 and 3 that's equal, and there's a true 0 point. So for example, take for example height. It's possible to have no height at all or no weight at all. There's a true 0 point. That means something in there. With that. And with this, with ratio variables, you can oftentimes have a lot of unique properties. You can do multiplication, division with these, and things retain their values. You can do add and subtract them, which a lot of these other ones you can't. Interval variables, you can add and subtract, but you can't multiply and divide them because there's no true 0 point. Whereas ratio, you do have the ability to multiply and divide them in order to create these unique properties associated with them. And I think that this image here really just gets a really good point as to what these are. So it just shows the ranking about, how it goes from, has a named part to a natural order to equal interval between variables, and then the ratio finally has a true 0 point. Now notice how interval, it says temperature. That's because the 0 point in temperature isn't a true 0 point. If we're talking about Celsius or Fahrenheit, the true 0 point isn't really 0 because there's negative numbers associated with it. However, if you're talking about temperature in terms of Kelvin, where there is a true absolute 0, that would be a ratio variable. So keep that in mind, that temperature can also be considered an interval because it is the 0 point doesn't represent a true 0 point. So now we've finally learned about measurements, and we're going to talk about a subject that I really like, which is measurement reliability. This is an extremely important topic in the terms of psychological research. Really, reliability is everything we talk about, and reliability is the reason we're able to make distinctions and talk about things. And then when we talk about validity too, we'll talk about the relationship between reliability and validity. So, reliability, it refers to how consistent the results of a measure are. So, think about this in terms of consistency. If I measure depression at one point, my guess is I should be able to measure depression at the next point, and it should be fairly similar, because someone who's depressed stays usually fairly depressed, without some sort of therapy or some sort of treatment. Personality is oftentimes a very stable construct as well. This is a variable that we are able to measure at one point, and usually it stays the same at a consistent time afterwards. Over long periods of time it might change, but after one measurement and a day after, it should be relatively the same. Additionally, if we're measuring height should have really good reliability. You should be, from one day to the next, you should have relatively the same height. So there's three types of reliability that we'll be discussing. There's more types of reliability out there, but we're going to talk about three specific ones. The first is test-retest reliability, then inter-rater reliability, and then we're talking about internal reliability. And internal reliability might be a little bit different than things that you've heard of before, but it's really the most important, it's a very important one out of all of these. So test-retest reliability is really what I was talking about with the examples before, where getting similar scores across multiple time points. So something like personality should be relatively stable across time points. So someone's extroversion score should stay relatively consistent across multiple time points. So from 1 week to the next, I would expect your extroversion to stay the same. The same with height or something like that. So height oftentimes has really good test-retest reliability, assuming you're using a valid ruler or measuring tape to measure it. If your measuring tape is off every time, then you're going to have very bad test-retest reliability with your measure. So now I want us to notice that not all measures are expected to have good test-retest reliability. For example, something like happiness fluctuates every day. You wake up every day feeling slightly different happiness than you did the day before, and especially from week to week, right? So there's events that can happen that can change your happiness. It changes very often. Same with sadness will change very often. However, depression is determined to be a very stable construct, assuming there's no intervention in between. But some things, like I mentioned before, personality traits are expected to remain stable and have high test-retest reliability. So, how do we test for test-retest reliability? A lot of testing going on. Well, we essentially just use correlation. So, you've learned about correlation in some degree in some of your other classes. If you need help with correlation, just let me know. But essentially all we're saying is, how does something on time score 1 relate with time score 2? And we're seeing either a positive trend, a flat line means there's no trend, and a negative line means that there's a negative trend. Really, what we want to see is a positive trend. So if the score on time one relates very highly with score on time 2, then we have good test-retest reliability. Whereas there's no correlation between the two, then that's bad test-retest reliability. And if you see a negative correlation, where their time point on one relates negatively with the test-retest on with their correlates negatively, then you have really bad test-retest reliability, saying one is the complete opposite of the other. So in order to test for this reliability, you look for a positive correlation, and the higher that positive correlation, the better test-retest reliability you have. Now we can talk about inter-rater reliability. This is when you have multiple observers, or two observers, or multiple observers. This is extremely important for observational measures. So this is the idea where we have two observers. They're observing some sort of phenomena. So let's say they're measuring how many times I touch my face in a minute or something like that. Theoretically, they should get exactly the same number. However, we know that people oftentimes don't record things at the same way. I may have been looking down when someone touched their face once when I was trying to record another one, and I missed that. So what we're trying to see is, do these raters score things very similarly? Now, it's not as relevant for self-report. When we get into internal reliability, that's going to become really relevant for self-report. It's somewhat important for physiological measures. So if I'm measuring, something like pulse, we want to make sure our raters get the same pulse rate across these physiological measures. So I provide you an example here. So imagine recording the number of times someone smiles during a conversation. If multiple people were counting the smiles, and you should have multiple people counting the smiles, there may be a little bit of error between each observer. And it's okay if there's a little bit of error. We're not perfect, but the more error, the lower the inter-rater reliability is. And what I'm going to do is I'm going to discuss how we actually measure inter-rater reliability. The way we measure inter-rater reliability is through something called Cohen's kappa. We're not going to get into kind of the statistics and how to calculate it, although I do give you the calculations here. You're really going to learn a lot more about this in Psych 350. But Cohen's kappa is a measure of agreement between raters while accounting for the fact that there's a possibility that the observers may agree by chance. So it's possible that these observers, they just sort of got onto the same thing. So it knocks you down for this idea of chance. So it's kind of hard to get perfect agreement between observers. Now, the way that we can look at this is it's really when you do this calculation based on the observer's agreement, and I want you to know this only works with 2 raters. If we want to talk about multiple raters, then we have to get into kind of more higher statistics, which I think you might learn about in Psych 350, but we're not going to talk about it here. So we're only going to talk about Cohen's kappa, which works with 2 raters. But overall, when you plug in your calculation, you get a range from 0 to 1. 1 indicates that there is a perfect agreement among raters, whereas 0 means there is absolutely no agreement between raters. It's pretty hard to get a 0 or a 1 with this calculation. However, we need to have some degree of understanding that there's going to be error between observers and be okay with that, because after all, we're not perfect, but we want to have a good amount of agreement. So if you look on your right here, you'll see this chart that says, if it's less than 0.20, it's considered poor agreement. If it's 0.21 to 0.40, it's fair, and so on. But really what we're trying to get is a Cohen's kappa of above 0.6 for a good degree of agreement between observers. Next is really my favorite type of internal reliability, which is internal reliability. This is also known as internal consistency. This one's a little bit different than the rest of them. This is where on a measure, the items on that measure, we want participants to provide similar answers to questions if it's measuring the same construct. So for example, and you'll notice I use depression a lot because I work a lot with depression in teenagers a lot. So for example, if I have a measure of depression, all my questions should be related to depression. So really, our individuals, our participants, should be answering in a way that indicates more or less depression. So we would expect participants who are depressed to answer questions, I call these items oftentimes, that indicate they are higher in depression. So I'm going to give you kind of an example of how this works on the next slide. We test for this with internal reliability. And the internal reliability is calculated using Cronbach's alpha. Now again, you're going to learn a lot more about how to actually calculate this in Psych 350, which is the next part of this class. But we calculate Cronbach's alpha using the equation on the upper right here. What it's saying is Cronbach's alpha is really telling you how closely a set of items are related. And again, it ranges from when you do this actual calculation from 0 to 1, and 1 indicating all items were answered completely the same, meaning that on a scale of depression, everyone marked the same exact score for the same exact amount of depression. Here, a Chromebox alpha above 0.7 is desired. So if you have anything less than 0.7 from this equation that you plug in, it's indicating that you don't have very good reliability here. So you're going to learn a lot more about this in Psych 350, but on the next slide, I kind of give an example of how this works. So imagine we're going back to the Center for Epidemiological Studies depression scale. All of these questions are in some way related to depression. On the left, I show you an indication of a measure of a participant response that would likely indicate lower internal reliability, whereas to the right, I indicate a point where it would likely have better reliability. So let's start off by looking at the left. You see these questions that are all related to depression. So it says, I was bothered by things that usually don't bother me. I did not feel like eating, my appetite was poor. I had trouble keeping my mind on what I was doing, or even I felt depressed. All those items, if someone was depressed or not depressed, would be answered in a similar fashion. We can even compare item 6 and item 12, right? So item 6 says, I felt depressed, and item 12 says, I was happy. If we look to the left side, we see that those were both answered at a 0. In reality, you would expect those to be oppositely answered, right? So if those are both answered at 0, it's indicating we have poor internal reliability. People aren't answering these questions in a fashion that indicates depression. Now, if we look over on our right side, we can see a little bit more consistency. It's not perfect, but we're having a little bit more consistency in item responses. This person here seems actually very highly depressed as compared to someone else who would answer mostly 0s. And if we look at questions 6 and 12 again, we'll see that actually those are responded to as opposites, whereas this individual feels very depressed and not very happy. So it's likely that those would be answered in opposite order. We use something called reverse coding in order to kind of score these. But overall, if you can kind of see the consistency in the right side as compared to the inconsistency in the left side, you understand what makes a measure more reliable versus what makes one less reliable. So now we're going to talk about measurement validity. So for measurement validity, what we're doing is we're trying to figure out how accurate or reasonable and or justifiable a claim is. So things aren't just valid or invalid though. It's not that simple. We have different degrees of validity, right? And even different types of validity that we're going to be talking about. So there's 4 types of validity that we'll be talking about. First one is content validity. Then we'll talk about criterion validity. We'll talk about construct validity, which can be separated into convergent and divergent validity. And lastly, we'll talk about face validity, which is actually a little bit different than all the rest of the validities, in my opinion at least. What is content validity? Content validity is essentially where we're assuring that a measure captures all parts of a construct. So let's talk about self-esteem. So for once, I'm actually talking about something other than depression, right? Thank goodness, right? So what makes up self-esteem? Well, we know self-worth is related to it. We know that someone with higher self-esteem oftentimes has higher self-confidence. They have higher self-disclosure and are oftentimes more open. So when we're taking a measure, we need to make sure that we're measuring all aspects that make up self-esteem. So there's other constructs that are related to self-esteem. So from here, we're making sure that we're measuring all parts of self-esteem in order to get this content validity. And think about it, it's the content that makes up self-esteem. And really, I think this image to the right has a really great way of showing how we're getting this content validity. We're creating questions for our operationalized variable of self-esteem that are related to these concepts that show someone has high or low self-esteem. Next, criterion validity. You'll notice I have a big stack of gold here. You might be wondering why. Well, this evaluates whether a measure is associated with a concrete behavioral outcome, or otherwise known as the gold standard. So, take for example, when I consider a measure asking about basketball skills. A measure with high criterion validity would correlate quite well with the average points they scored in a basketball game. Because really, your basketball skills should relate to how many points you score in a basketball game um, overall. So, if your basketball skills are very well and you're an offensive player, you would be expected to be scoring a lot of points. Um, so a measure with high criterion validity will measure quite well with that. So if I'm asking you questions about your basketball skills and you say, I'm really good at basketball, I score a lot of points in the game, oftentimes have control of the ball, then that would indicate that you're likely to score a lot more points, which would be the gold standard in this case. There's other things where other measures are considered more better criterion validity, have higher criterion validity based on how they relate to other measures. The next one is construct validity. This one is how the construct of interest relates to other constructs of interest. It's relatively similar to content validity. The difference here is what we're looking at is correlations between different constructs. So we'll talk about self-esteem here, right? So if we look at the picture to the right, we see that self-esteem is oftentimes related to achieving better in school and ability to cope in there. Now, with construct validity, there's two parts of it. There's convergent validity, so how well your measure positively relates to other measures that are similar. So this is a positive correlation. So we expect self-esteem, so we expect higher self-esteem to positively correlate with a higher ability to cope. So as your self-esteem rises, your ability to cope rises as well. Additionally, there's divergent validity that's associated with construct validity. How well your measure negatively relates to other measures that are similar. This is a negative correlation here. So if I have higher self-esteem, it should likely negatively correlate with my distrust for friends. Someone with higher self-esteem oftentimes has more trustworthy friends or has a higher trust in friends as opposed to their lower self-esteem counterparts. Additionally, there's no real word for this, but your measure should also not relate to constructs that have nothing to do with it or have a zero correlation. And on the picture on the right, you can see this by self-esteem having a zero correlation with liking coffee. So essentially, my self-esteem has nothing to do with my ability to like coffee or not. If I have higher self-esteem, it doesn't make a difference on whether or not I like coffee. These are two completely, absolutely unrelated constructs of one another. And our last validity type is face validity. This is a subjectively plausible operationalization of the conceptual variable. We don't really have this correlative practice associated with this, but really all you're doing with face validity to have higher face validity is it's determined by consulting experts in the field. So let's take this for example. I have a measure on school performance. I would expect an expert in the field, so for example, a teacher who is an expert in school performance, to agree that my measure appropriately measures school performance. So really, this is saying if I'm going to go consult an expert in the field to determine if my measure is valid or not. This one's a little bit different than the rest of them, as you notice. But it has real huge implications with the field, right? Because when you want high face validity, someone who's an expert in education, like someone who has a PhD in education, should agree that your measure is associated with school performance. If I have a measure and it asks how much the student likes coffee, how is that in any way associated with their school performance? Really, the measure would be asking something like this: do you get A's in class? Do you enjoy aspects of school? Do you perform well in school? Is what it's associated with. And an expert should agree that is a valid measure because they work in the field quite often and know what a good measure is. So, in summary, we kind of covered a lot in these actually last 2 units, but measures are a common tool used in psychology to measure conceptual variables. They're used to operationalize those variables. Overall, there's 4 levels of variables. There's nominal, ordinal, interval, and ratio. And remember that it's not necessarily that one's better than the other, but rather they're just different characterizations of variables. Nominal would be things like measuring sex. There's no difference between 0 and 1 or male or female. Ordinal is where there's that first place, second place, third place, where although there's a bound order, we don't know how different they are from each other. Interval is oftentimes those Likert scales, or even things like temperature, where there's no true 0 point, but it does have an equal interval between 1 and 2 and 3. And then ratio would be has a true 0 point. So like time, if I were to time the race and say you got finished in 5 minutes, you finished in 6 minutes, there's a true 0 point because 0 means 0 minutes recorded. Additionally, we talked about reliability, which can be measured in 3 different ways. There's inter-rater reliability, test-retest reliability, and then there's that internal consistency reliability. And remember, those reliabilities you're going to talk about a lot more in the next Psych 350 when you go on to higher education classes, but we do really talk about it, and I'm going to talk about them more often too as we go on progress through this class. Additionally, validity comes in many different forms, including content validity, criterion validity, construct validity, and face validity.